Hello everyone, we are FunctionPy. Today is our first video. I want to present how we solve a problem that is discussed warmly on China website Hupu. This is a problem. 4 small ducks are placed in a large circular pond, and they are randomly placed at any points inside the pond. The question is, what's the probability that 4 ducks are placed in the same semicircle? Let's start by analyzing the problem. Connect the center of the circle and the position of the duck so that we can get a radius. The probability that each duck appears at any point of the radius follows uniform distribution. Hence, we can transfer the position of each duck to the intersection between the circle and the radius it is placed on. Now, the problem transfers to 4 ducks are on the circle. What's the probability that they are placed on the same semicircle? Following the strategy, we will give 2 solutions in the video. For the first one, we're going to make use of integration to solve the problem. The radius each duck can cover is 2 pi. Imagine each duck as a point. Let's assume the 4 points are placed on 4 different circles, and rearrange the 4 circles. For each arrangement, there are 4 factorial same conditions. Hence, all the conditions of the radius that the 4 ducks can be placed on is 2 pi with power of 4 over 4 factorial. When the 4 ducks are placed in the same semicircle, connecting the positions of the 4 ducks to the center of the circle, the angle included by the radii passing through the 2 ducks on the edge must be anyone from 0 to pi. After the angle is confirmed, it can orbit around the center of the circle with a radius of 2 pi. Let the angle included by the radii passing through the 2 points on the edge be theta. And let's assume the other 2 points are placed on 2 different arcs with angle of theta. Rearrange the 2 arcs. Each arrangement has 2 factorial same conditions. Then all the conditions of the radius that 2 ducks can be placed on is theta squared over 2 factorial. Hence, when 4 ducks are placed in the same semicircle, we can calculate the position of them through using the following integration. It is okay if you haven't learned integration. Next, I'm going to explain the meaning of the integration. It means that if we orbit the angle included by the radii passing through the 2 points on the edge by an angle of 2 pi, and times it with all the conditions of the rest 2 points can be placed on, the product, pi with a power of 4 over 3, represents all the conditions of the position of the 4 ducks when they are in the same semicircle. The probability that 4 ducks can be in the same semicircle is the positions they can be placed on when they are in the same circle over all the positions, which is 1 over 2. Promoting this to the condition of n ducks, the positions n ducks can be placed on is 2 pi with power of n over n factorial. When n ducks are placed in the same semicircle, the position of them can be expressed with the following integration. It means that if we orbit the angle included by the radii passing through the 2 points on the edge by an angle 2 pi, and times it with all the conditions of the rest n minus 2 points can be placed on, the product 2 pi with power of n over n minus 1 factorial represents all the conditions of the positions of the 4 ducks when they are in the same semicircle. The probability that n ducks can be in the same semicircle is the position they can be placed on in the same semicircle over all the positions, which is n over 2 with a power of n minus 1. Next, we will introduce a second method to solve the problem. It is relatively easier to understand, and we use the idea of combination and permutation to solve the problem. Cut a circle at one point and straighten it into a line segment. The length of the line segment is 2 pi r. If 4 ducks are placed in the same semicircle, we put the duck on the extreme left on the center of a line segment. Hence, when the 3 ducks left are all in the right half of the line segment, the probability for 1 duck become the one on the extreme left is 1 over 2 times 1 over 2 times 1 over 2 is 1 over 8. As only 1 duck can become the one on the extreme left, and the conditions for each 1 duck to become the one on the extreme left are independent, the probability for 4 ducks to be in the same semicircle is 1 over 8 times 4 is 1 over 2. Promoting this to the condition of n ducks, the probability for 1 duck to be the one on the extreme left is 1 over 2 with the power of n minus 1. The probability for n ducks to be in the same semicircle is n times 1 over 2 with the power of n minus 1 is n over 2 with the power of n minus 1. Above are all for this video. Thank you for watching. See you next time.